by putting it more so that I can maybe also take an example. So the big question about artificial intuition is first, what is intuition? And when people speak about intuition, they speak about a form of knowledge or having ideas where you don't really know how it is that you come to a particular conclusion. So the best way to define intuition is in a sense to contrast it with its opposite. The opposite you might call is rational thinking. And you have the famous distinction made by Kahneman, Nobel Prize in economics, who speaks about system one thinking, system two thinking. The system two thinking is what we usually call rational thinking. That means that you explicitly form certain arguments in your mind and you follow the train of thought step by step. That means you use symbols, which typically are words, which represent certain entities or certain concepts or categories. You have certain rules to which you combine these symbols into meaningful sentences, or in what it is called propositions. Propositions are either explicitly describe some kind of situation, and then you follow certain rules of logic or grammar to derive things from other things. Like there is this classic example: Socrates is human, all humans are mortal, therefore Socrates is mortal. So you have the symbol Socrates, you have the symbol human, the symbol mortal. You know that there are certain rules of grammar by which you can make sentences like Socrates is human, humans are mortal. We have certain rules of logic that says if all humans are mortal and Socrates is human, then Socrates must be mortal. So for a very long time, cognitive science and artificial intelligence was starting from this kind of symbolic paradigm. The symbolic paradigm of rational thinking explicitly, step by step. And that was, let's say, until about the 1980s, there was the idea we can represent all knowledge by symbolic expressions. And the height of that, let's say, that paradigm, artificial intelligence, was in the 1980s, the so-called knowledge-based systems or expert systems. They were trying to code every knowledge we have about the world in terms of these kind of propositions. So kind of propositions that we would want to have is, for example, a dog is a mammal is an animal, a mammal is warm-blooded, a dog barks, a dog walks in the streets, and you would try to describe everything there is to know about a particular domain in explicit propositions consisting of abstract symbols that follow certain rules. Why am I seeing something that is not me? I see everybody's watching a screen where there isn't anything to do with what I'm talking about.
You needed the whiteboard, yeah. So now it's coming. Yeah. Oh, the button, sorry. Funny.
So this idea was that artificial intelligence, it necessarily requires.
বলছি যে আমার সাথে একজন লয়ারের কথা হলো, মানে ইনিশিয়ালি আমি সিচুয়েশনটা বললাম, তো সে বেসিক্যালি ওটা ফলো, মানে ওর যে সিনিয়র এবং আমার সাথে যার কথা হলো সে বেসিক্যালি কর্পোরেট লয়ার, কিন্তু সে আমার পরিচিত
yourself. Yeah, it's muted. So we need to, can you stay to just in case of anything? Or I stay.
Yes, and please, can it be a little bit louder, the microphone? So maybe try, Francis, if you can try to speak more in front. When you turn the head, then it's missing what you say.
Okay, that's why I didn't speak if you there. Yeah.
I'm sorry, I know it's very difficult. It happens to me also. Last week.
Yeah. Please keep going. I can see the sound here, so it's okay.
So we are in this paradigm, which is called in cognitive science the symbolic paradigm. knowledge consists of symbols. Symbols are
I think you have
combined
to.
according to certain rules in propositions. Propositions describe your knowledge, they describe what is to be known about the real world. And then intelligent reasoning is making inferences. That means starting from some proposition that you know to be true, you derive other propositions. For example, knowing that dogs are mammals, that mammals are animals, you can derive that a dog is an animal. Knowing that mammals are warm-blooded, you can derive that the dog is warm-blooded. So that was the paradigm in the 1980s of the so-called knowledge-based systems. And because it's not obvious to put in all the knowledge we have about the world, it started with so-called expert systems. The expert system was meant to represent expertise, that means specialized knowledge about a particular domain. And one of the typical examples they were considering was diagnosis of diseases. If you are a doctor, you know that this disease can have these and these symptoms, and that if you have a high temperature and you have a cough and you have this, then you may have an infection of the lungs and so on. So one thing they immediately needed to do was not only logical derivations where A necessarily follows from B, but also some degree of probabilistic derivations. If you have these symptoms, then you may have this disease with this probability and this other disease with this probability. So that was the paradigm in the 1980s, and the idea was, yeah, the whole of artificial intelligence, the only thing we need to do is put in more and more propositions, more and more rules, and eventually we will have the knowledge of the whole of humanity in our artificial intelligence system. And there is an interesting project that started doing it, and that project is still running. It's called Psych, made by the artificial intelligence pioneer Douglas Lenat, and the idea was, let's capture all the knowledge about everyday things, the kind of knowledge that an average person has into these propositions. And that could be very simple propositions like, when it rains, the street gets wet. When it rains, people take an umbrella. An umbrella protects you against the rain. If somebody is sad, they will not want to go to a party. And I mean, you can think of thousands, millions, and in the end, billions of these kind of propositions. And of course, this Psych project put millions of these things into the system. And in the end, yeah, nobody has really heard, I suppose, about the Psych project. They have put thousands of man years into collecting all this knowledge and, yeah, practically not used. So nowadays we have artificial intelligence systems that are much better than that, but they work according to a completely different principle. So in artificial intelligence, you had the symbolic paradigm, the paradigm of explicit logical thinking, and then you had the connectionist or neural network paradigm. And that is the paradigm that is more trying to imitate what happens in the brain. And that is precisely where what we might call intuition is happening. Because what is intuition? Intuition is you suddenly have a certain insight or a certain feeling that something is going to happen. And you can't retrace the steps. You can't say what are the assumptions I have made and what are the inferences I have made to come to this conclusion. The conclusion is there, it's kind of obvious. You see somebody, you say, oh, that person is sad, maybe they just had some bad news, and you go and you comfort that person. Why did you think that that person was sad? It's not obvious. Maybe it's the way the person was moving kind of slowly and looking kind of like this and not reacting when you ask something. You can recognize that that person is sad. Intuitively, it's clear that that person is sad. There wouldn't be any kind of an expert system that you could put in rules if the person's eyes are with this angle down, and if the person's movements are slower than this, and if this and this, then the person is sad. Obviously, that doesn't work. So the symbolic paradigm for artificial intelligence, I wouldn't say that it's outdated, it's still useful for certain things that can be formalized. But the big advantages in artificial intelligence like now are about this neural network paradigm. So neural networks get very quickly very complicated mathematically. So I'm not going to try to explain that here also, because I don't know the details, but I want to explain two basic principles which I think you should know. The first principle is the so-called Heylighen rule, which says that if something occurs together with or shortly after something else, the brain tends to make an association between them. And the more often the one thing happens and then the other things happen, the stronger the association becomes. So for example, if you're a little child, you don't know anything about the world, you see a dog, let's call it A, and then you hear a bark, you see the dog barking, let's call it B, you make a connection from A to B. Now, if it just one dog once barked, there will already be a connection, but it will be pretty weak. But if now that kid several times that it sees the dog and then the dog at some moment starts to bark, this connection will become stronger and stronger. So what Heylighen learning does is it strengthens connections between things that tend to co-occur, that tend to occur together. So that is, you might say, the most primitive level of learning in the brain, connecting things that tend to occur together. It's called associations. That is associative learning. You're making associations, but the associations are not logical inference. It's not because something is a dog that it will bark. It's not because somebody is like that that they are sad. But if they are like that, there is some association that tells you, well, they might be sad. So an association is something that can have a strength or a weight, and it's called in neural networks a weight that can be between, let's say, 0, meaning there is no association, and 1. It's always the case that, for example, logical rules can be expressed as things with an association strength 1. If it's a cat, then it is a mammal. If it's a cat, then it is a pet. Well, not all cats are pets. Some cats are wild, but it's a pretty strong association. If it's a cat, then it's cute. Well, maybe for some people it's cute, but some people are afraid of cats, so that's a weaker association. If it's a cat, then it's black. Well, there are quite a lot of non-black cats, but you're more likely to see a black cat than to see a green cat or a red cat. So associations can have all these degrees of strength, but that's the one rule. While we are experiencing the world, we are constantly learning associations. We are constantly experiencing different things together, and either they are together often, or they are together rarely, or they're together from time to time. The brain is very good at capturing all these kind of associations. So the association idea already gives you an idea where intuitions come from. If there is an association from A to B, well, then B may pop up when you see A without you necessarily knowing that there is a route A to B. And it's especially noticeable, of course, if there can be lots of in-between steps, and maybe your brain is going from A to B to C without you being really aware of it, and then suddenly you think, D. But your brain may have done a lot of intermediate steps that you're not aware of. And then there's a second principle. It's called spreading activation. The idea that you see A, that means A is activated in your brain. You see a dog, in your brain is the notion there is a dog. You have a number of associations with dogs. You know that dogs bark, you know that dogs have 4 legs. you know that dogs tend to wag their tail, even though at that moment the dog is not wagging its tail. You have some kind of an expectation that at some stage a dog may be wagging its tail. And in a sense, that's already an intuition. You might say, I see a dog. Intuitively, I kind of expect that maybe when the dog comes up to me, that it may wag its tail. And then you could say, ah, yeah, it's wagging its tail. But now, spreading activation means that you activate one thing, and you don't go from A to B to C to D, you go to lots of different things.
Nobody goes there.
So the activation spreads to lots of things, but it spreads not only outward, it only also converges. Because now from Y, it goes in different directions. And maybe X and Y together produce W, and W and let's say Q together produce something else. The way this is modeled in neural networks is with activation that is divided. So suppose that A has a lot of activation, and there's a strong link to B. So a big part of the activation goes to B, smaller amount goes to X, a smaller amount goes to Y, but then X and Y together leads to W, which means that W will again get more activation because it gets activation both from X and Y. So activation can both spread in the sense that it gets diffuse, and it can converge in the sense that from different directions, from different things that are activated in your brain, something gets a lot of activation. And now we get this phenomenon that you may suddenly get this insight, and you say, ah, yes, that's it. Where did the insight come from? Probably from lots of different things that were activated a little bit and that somehow converged. And together they came to something that is strong enough that it pops into your consciousness and you say, ah, yes, that's it. So what intuition does is it allows you to look at all these fuzzy, uncertain things that may or may not happen, that are more or less probable, and it can diffuse so that you don't know very much anymore what's going to happen, and they can converge so that suddenly out of this diffuse thing, you suddenly come to an idea, say, ah, yeah, that's it, I have understood it. Most of this spreading activation is subconscious. That means we are not aware of it, we don't remember it, we can't say what are the intermediate steps. So we may, for example, at a certain moment start from A, strong enough to be conscious, a number of intermediate steps, converting in R is strong enough to be conscious. The intermediate steps were subconscious, you don't know them. So your intuition says, ah, this is going to happen. This is what you originally started out with. All these intermediate steps you don't know. So that is why intuition typically is considered as something mysterious. Something that for a long time people have thought machines will never have this intuition. It's not possible to artificially design this actual intuition. That was because we still had this idea of machines, computers, following logical reasoning, step-by-step, explicit paths. That's not how the brain functions, and it's also not how modern artificial intelligence systems will function. The modern present-day systems, they use this kind of networks. Not exactly the way I have sketched it here. It's very complicated, and as I said, I'm not going to go into any detail, but the principle is the same. You activate a number of artificial neurons that stand for different features of the situation. For example, you have a text reading system. It reads a word, it reads another word, it reads another word. It activates each of these words, and then it activates a particular combination of words, and out of that combination of words, it anticipates that another combination of words is likely to follow. And that's a little bit the principle of these large language models like ChatGPT. What they do is you give them an input of a number of words, they have looked at millions and billions of sentences. So they have some kind of, you might say, intuitive idea of which words will follow. And the way they are worked is that they are, in a sense, continuing the conversation. If the conversation starts with this sentence, they have some expectation that the following words and sentences would follow. And that's what they are doing. They are, in a sense, following their intuition of what would be the next things to say. But following their intuition means you don't know exactly how they come to their conclusion. You also don't know whether the conclusion is correct. It's not a logical process. It doesn't use explicit rules. So some of the intermediate associations may actually be inadequate. And that's one of the problems they have with these models like ChatGPT, is that sometimes they very explicitly tell you things that are wrong. That's because they have learned in this intuitive way, the way people also learn. And then people say, oh yes, but that's horrible, that they might say something wrong. But people, of course, also tell you sometimes wrong things with a lot of upward. I know it, that is the case, that's going to happen. Yeah. In a sense, these new language models are more like people in the sense that they work more in this intuitive way. They spread activation fuzzily over many, many different things, and some of that activation converges to produce certain sentences and certain words. And then often it sounds good, but it may be wrong. So that is a bit the idea of artificial intelligence. You're using a system of associations and interconnections and spreading activation where nobody really understands what's going on, even the system itself. You cannot really reconstruct all the steps. There are no explicit reasoning steps, and therefore you can solve a lot of problems that you wouldn't be able to solve logically. But sometimes you can, of course, also make mistakes. Yeah.
So, what about back propagation in your story? That's what's going on with the brain. Back propagation the roots of the spreading activation.
Well, I haven't mentioned a second learning mechanism. I spoke about Heylighen learning, which means when two things tend to occur together, you strengthen the connection. There is also a different form of learning, reinforcement learning, which says you follow a number of steps, you come to a certain result. If that result is what you wanted, you reinforce it. It means you reward whatever process led to this result. If that's not what you want, if it's a mistake, then you might say you punish or you inhibit the process. That means all the different steps in the process that led to the wrong result are weakened. So it's a way to learn to avoid mistakes. But first, the system should produce an output, and then somebody should be able to say, this is right or this is wrong.
Something. Because it's a penalty function.
Yeah, but there needs to be some explicit decision that it is the right result or that it is the wrong result. So you can take things like that, but it's much more complicated than the Heylighen learning. In the Heylighen learning, you just feed it monstrous amounts of text. It learned that certain words and certain phrases and certain ideas go together, so that whenever it recognizes some of these words, phrases, or ideas, it tends to follow them up with the ones that most commonly follow them. But here there is no explicit function that tells you it's right or it's wrong. You can do that in the later stages, the reinforcement learning, by either punishing or rewarding the system for wrong answers or right answers. But that is indeed, that takes much more time.
But, oh, okay. I just briefly say, in principle, though, it's the same mechanism, right? If you think of it as an extended mind, it's still a coincidence between like a literal coincidence between the event and the reinforcement, which then strengthens the network.
Well, it's the same mechanism in the sense that you strengthen certain connections relative to others.
Yeah.
Strengthen some, weaken others. That is always the mechanism. So it's not like you say that suppose that you have an expert system with logical propositions and you see that it comes to a certain wrong conclusion, you can try to find out where was the step where it made the wrong conclusion, and you see that particular proposition in there is wrong. And then you say, okay, I'll take that proposition out and replace it by a correct one. Here, we can't do that. Here, the whole system, the whole network has come to a conclusion with methods like backpropagation, which is typical for deep learning, and I must say I don't know the details about it. You try from the end result to reason backwards to all the different steps that have led to this end result, and then you either weaken them if the end result was bad, or you strengthen them if the end result was good. But these are things that mathematically are very complicated, so I don't want to speak about that.
Thank Francis. We will have a discussion session after Christian's talk. So thanks, Francis. Was made. This is yes.
I'm gonna move the laptop over here.
I'll fill the gap. So this was Christian Jendreiko's presentation. Sorry, Francis' presentation. Now we got Christian Jendreiko, who I will introduce you if you want to say something else after.
Yes, if you go here, I can start.
Okay, great. So Christian is a professor of communication design at the University Hochschule Düsseldorf. So he comes from Germany. And he's a theologist and a communication design professor, a very passionate researcher and creative musician as well. So you will tell us about your story, but please, I guess you can introduce yourself as well. So thanks, Christian, for coming. Thank you. Yeah.
So Thomas, you downloaded
It's
the
in the
slides
desktop.
here.
Desktop.
On the desktop?
Yeah.
The slides are here somewhere.
From the newest file. You can go to downloads maybe on the website. I create a window. No, desktop.
Desktop.
That's everything. That one. Christian Jendreiko.
Great.
And then just the function that.
And then we go to Zoom back again.
Okay.
It's a little bit, there's something strange going on. So it's like doing this double desktop thing, right? So it slides across. But now what I have to do is go to the share screen, which is
The green button. Yeah.
here. Okay.
Yeah.
Share screen.
Share screen. Just share screen.
But I press that.
Yeah.
Okay.
And then you have to find.
Then we have to choose the right one.
Yeah.
Okay. And then none of them are coming up. So
It must be Acrobat.
I think you have a punishment for running go to the screen that really doesn't have access to the share screen.
okay.
So
Do you know how to maybe
Because
you're fast.
I have the file in my phone too, so maybe I can share it. So
There we go.
You get it?
Yeah, open system settings.
So it needs to have access to screen recording. You just put your finger. Okay, you can reopen. Oh, are you host?
Yeah.
Okay, then we need to be careful. I put you host. Who's here? Thomas, I put you host.
But I can try to share the slides from here too.
That should work.
Yeah, let them in. That's cool.
Yeah, you have.
You left the Zoom. Is there anybody that I can trust that will give us back the host permission?
Yeah, everybody there is well that we.
Who wants to be a host for 2 minutes on the Zoom, please?
I am connected, no?
No, you're not.
You're out somehow. You left the call.
Yeah.
Yeah,
Good,
I
good.
could also do it. Yes, please, Katerina.
How come I
Somebody on the Zoom, is somebody active to take the host and give it back?
I might be muted. No, I'm not muted.
Katarina, it's are you connected
Please
already?
write something on the chat or.
Yeah.
Okay, thanks,
Santiago. Cool. Thanks, Santiago. Got it.
Okay, and now you should be able to share. Oops. Sorry.
Yeah. Okay. Now try to share the screen again. Oh, so
Santiago, just put us back on host, please. So you right click on the name and click on assign host, I think.
Nice.
Oh yes.
Now you can.
okay, great.
Yes,
Now
right.
share screen.
Ah.
Okay, we're back. And
That
now that was slick.
That was
Clement.
not artificial, very intelligent. Yeah.
Desktop
Hacker.
whiteboard.
Thanks to the hacker. Yeah. Is it that one?
Oh yeah, cool. Right.
Yeah. Now
Yes,
share.
share.
And
Okay. And then we can go from here to full screen, right?
Yeah.
So in the meantime, while Christian comes to the room, I would like to remind that we have a mission today, which is because some people were coming, which is collecting the right questions that we have to ask around this topic. So please remember, this is a question I think. So
Okay,
data
Christian.
collection,
You wanna?
Yeah.
I think you
Forward.
maybe just like this. Hopefully, no. This. You just do a little swipe.
Okay. Great.
Yeah,
Great.
Is that good?
Yeah, that's
Okay.
perfect. Great. It's the bottom. Yes, thank you for having me here in Brussels. One more time, I will talk about, title is Towards the Modeling of the Formfindungsprozess. As Thomas said, I'm a professor at the Faculty of Design at the University of Applied Sciences in Düsseldorf. And I'm responsible there together with my colleague Stefan Asmus for the module of systems. And my main field of research is the modeling of the Formfindungsprozess in an aesthetic creative process. And Tomas mentioned it already. I belong to the movement of free improvisation. That's where basically I'm coming from. And doing this free improvisation thing, you really start to try to understand how does it work if you play together with other people. How does it really work that you create together something which you didn't know before will happen? And out of this question, so we started out when we were 16, and out of this thing, these questions of research did arise. And here you see us performing. This is in the middle. You see me and Stefan Werni, and some of you know Stefan and me. We've been here at the Great Systems at CLEA Symposium in February, performing here. And on the left you see Vivian Cunningham, and on the right you see Maggie Nichols, and both belong to the British free improvisation scene, which is an interesting thing in itself, an interesting development. And we did perform 2 weeks ago. We gave this concert, and it's one of these situations, you know, where you meet together and then you start to perform with each other without talking before you do something, without knowing what the other will do. And to describe, and how can we describe this situation? And I brought this basic a diagram from Robert Rosen, which exactly, I think, describes on a basic level this situation. You have, on the one hand, you have the natural system that you want to describe, and on the other side you have the system of description, and it also goes already in the direction of what Francis did say, that you have these theorems and inference rules, and then the interesting part is that you have on the one hand you try to decode the natural system you observe and trying to understand. And at the same time, then with this system, you encode what you see there, the natural system and its causalities and everything. And so I think this is an interesting diagram to get an idea of what this process of formalization, what is happening there. Although I must say this is not on the neueste Stand, I would say, as we say in German. It's not actual, but this is a good introduction to what the problem is if you try to formalize a process that you observe. And of course, we can dig deeper in here into questions of entanglement, in how far these systems are entangled with each other, and do they produce each other, and questions like that. But this is something else. Well, so these are my basic research questions, and via a friend and colleague, Markus Wetzler, he was in contact with Katarina Petrovic, and Katarina did invite me in 2019 to give a talk about my research project right here, and I called it Artificial Intuition. And this was a great session. It was Orion was also here, Katarina was here, and Francis was here also. And we had afterwards we had a deep discussion, a deep fruitful discussion for me at the CLEA house. And I had another idea then how to describe, how to try to find the right approach to describe it. And Francis then introduced me to the idea to use, to try it with chemical organization theory. And so I got into contact And Francis brought me into contact with Tomas Veloz, and I invited Tomas Veloz to our university in early 2020, I think it was. And so we really started to work with students in different projects, really try to apply COT to these questions and experimenting with it, because this is an important thing for me too, that it's about experimenting to try to understand better the process of the Formfindungs process, that you apply, also try to apply different paradigms. It's like Francis pointed out, these two paradigms in artificial intelligence, that you have on the one hand, you have the knowledge-based symbolic paradigm, and on the other hand, you have the neural network deep learning paradigm now, and two different paradigms. And it's we have the chemical organization theory. So this was just to show this was a project that was developed by Tomas Veloz and Vincenzo De Florio, and we experimented a lot with this in different seminars, in different setups. Yes, and then I was invited this year in July to the ICLP conference in London as a speaker. It's the International Conference of Logic Programming, and I got there into a deep discussion. I was invited by Veronica Dahl. She's in the middle. She's one of the experts of logic programming and logic grammars. So this is exactly system 2 that Francis was talking about. And on the left, you see Robert Kowalski, and he's one of the pioneers of developing the knowledge-based logic symbolic paradigm, trying to implement it in form of software, which was happening in the mid-70s by the programming language Prolog. And I got into a deep conversation with Robert Kowalski on this conference, because his thing is backward reasoning and forward reasoning, and trying to implement, or they succeeded to implement backward reasoning as in form of software, in form of SLD resolution and backtracking. And we got into this deep conversation because Robert Kowalski was saying that he tries to understand so we were talking about creative process and how to formalize it and other possibilities. And he was talking about that he tries to find.
So Gabriel is coming.
Okay. And his question was and still is, in the creative process, how often does backward reasoning switch to forward reasoning and back again? And I talked to him that when I teach my students, I explain backward reasoning the following way. Backward reasoning is Michelangelo, when he says that if he sees the block of marble, he can see already the figure within the marble. And this is a kind of backward reasoning, because you go from the result, you can see the result, and then all you have to do is going backwards. This is what Francis pointed out before. You can go back step by step, and then you know how you achieve this goal by backward reasoning. And forward reasoning, I described to the students with Jean Miro, who lived in Mallorca, and went every morning down to the beach and looked what the ocean has brought overnight, and picked up the different bits and pieces at the beach. And so data driven, you could say, in kind of a way that he takes this and that, and out of this forward reasoning process, he suddenly sees what the figure can become. So these two, Robert Kowalski, he said these two things seems to be good descriptions of backward reasoning and forward reasoning in the creative process. And Tomas and I, we had this idea that we worked together from 2020 on ever since. And so I talked to Tomas about this, and that I wanted to try out. What about if we really try to formalize? Could this be a way that we formalize? I know it sticks. Can't move it. Or do I have to go on this? Okay. Yeah, and Tomas came to Düsseldorf, and we had an intense working session for 3 days, thinking about backward reasoning and forward reasoning. And is it possible that we can create a pattern out of it? Can we see the pattern, and what are the perturbations maybe? So we were trying to get together chemical organization theory and this idea of backward reasoning and forward reasoning, and see if patterns of the switching of both do emerge. 3 intense days. Yeah, here you see it gets fuller and fuller, the blackboard, and here you see a draft of our ideas and how it could work. Don't want to go too much into detail here. The interesting thing which I want to put on the table here was our conclusion of these 3-day sessions, that we have a big question, and that is really, on the one hand, if you think about what Francis pointed out with System 2 by Kahneman, and the whole approach of trying to formalize such a process as the form-fitness process, that you have, on the one hand, this paradigm of, we named it, or Tomas did name it, clockwork engineering. So where you really have separate units, where you think in the system that you observe and try to describe as if there are separate units, and each unit has a certain function. And out of this, you get this functional sequential thing that is working. And so this is the paradigm of, we can say, the technological society. And on the other hand, and COT as a tool seems to point into this direction. That's why we couldn't marry these two things really in our approach within these 3 days. On the other hand, you have this thing that really trying to capture a Formfindungsprozess. It is really more about a more organicistic approach. We were talking about it. And the question is, so we have these 2 paradigms, you could say, of trying to formalize things. You have the clockwork engineer approach, and you have the more organicistic approach, which is about to be developed. And I think this is what we are working on. If I'm allowed to say, I think it's or at least it seems to me that this is really happening at CLEA with other projects that are going on, that this points towards a more holistic, a more organicistic description of such processes, but we still don't know really how to. And this is, so we are on our way, and this is what I want to bring on the table for today. Yeah, thank you very much for your attention.
Thank you, Christian. Now we have an open discussion for nearly 40 minutes. So there are some people here that maybe would like to intervene or say, bring something in. Maybe people in the audience, online audience as well. So if anybody wants something to say or has a question, okay, we can start. I will moderate. Okay, Clement. I will.
So, it's say that backward reasoning is a way to kind of convergent thinking, whether it's forward exploring possibilities. Yes, in a way. It's very obvious that the forward thinking is forward reasoning is now explorative. not really. If you get it closer, and it's this, and this was the conversation I had with Bob Kowalski. It's really switched between these two things, you know. And one, when is this switch happening during a creative process? This is the exciting question. If you really stay in the description paradigm of system 2, taking from
But if you keep this microphone, because you will be speaking here, otherwise we will lose. So I will open up this.
Where do I?
Okay, but then we won't hear people online.
We will.
We will.
On and off, so
Okay.
Okay, so now, just summarize the question again. You were speaking about backward reasoning.
Yes, I was just asking whether it was a good summary to say that backward reasoning is a kind of convergent thinking because you want to narrow down your goal, where you want to go, whereas forward reasoning, you're exploring more possibilities, you're more divergent. You said it was not so simple.
Yeah. I think the way, because it's a combination of both. Or this is at the moment, the way we are thinking about it. Because you could look at backward reasoning, so you have a clear result in your mind, the goal you want to achieve, and then you have to break down the different steps to get there. But you know them. And so you know the result is there, and now I have to prove how to get there. But while you do it, you suddenly get distracted from this way of thinking by a perturbation. This was, so Thomas and I were talking about perturbations in the sense of chemical organizations, and so where do come the perturbations in, which is an association actually. So suddenly I see, oh wait, this I'm doing something, I'm playing something on the synthesizer, and suddenly this reminds me of something. This is exactly that thing, and then I switch to forward reasoning, because then I say, okay, I have this thing, and now I combine it with what? With that thing. Oh, and this gives, I see, because this now fits to the rule that I can turn this into this and that. You know, and this is, and then if you have achieved this local kind of thing, you switch back to backward reasoning, because you know, okay, so this part is through, and now I can go back to my initial idea.
So maybe you continue until you reach a certain kind of consistency that tells you now it's time to explore again.
Exactly. Yeah.
Or maybe be bored.
Yeah.
Okay.
Yeah.
Went around this.
And it was super interesting when we were performing with Vivian and Maggie, because we had a long conversation before we started and a long conversation afterwards. And I observed myself and ourselves while we were performing, and this was what became clear to me also, which is a kind of different thing, which goes more into parallel things, that you have maybe running the backward reasoning all the time, because you have certain results you want to achieve for sure. For example, don't be louder than the other ones. So you have this running. How do you do it? Different steps, because suddenly you got this association, and you know, I have to be loud now. But
but backward reasoning tells me, no, I can't be loud at this moment. So I have to combine these things, but I still don't know how. But this was now the actual thing that was going on.
It depends. Sorry, it
Yeah,
depends also on the genre. Like in jazz, you can give the volume to one instrumentist, and then it switches. Like if you have a good idea,
Yeah.
then all the musicians
Will go
will
down.
and
Yeah.
will listen to.
Yeah.
one
Yeah.
instrument.
Yeah, the last time I was here, as an example, I was talking about the Rolling Stones, as a unity where because it's so you can have different kind of things, but at the end it's you can look at these things as if it is always improvisation. It doesn't matter if you have a theme that you are playing together with the band, or if you have no theme at all and the theme emerges. So if you do free improvisation, the theme emerges. If you have a theme, like let's say Rolling Stones are playing on stage, I Can Get No Satisfaction, then you have the thing going on that a special version of this theme will emerge while they are performing it. And you have the same, and I guess you have the same structures or processes going on, And these kind of things we are trying to get closer to, because the thing is that I use formalization really to understand, to get a better understanding of what are we doing when we do free improvisation. This is the whole task.
Okay, thanks, Aloha. Yeah, just some associations with that. So Eduardo Bono describes this process quite well. In terms, he coined this phrase lateral thinking, and he has this idea as well that like forward thinking is thinking that doesn't know where it's going. In fact, like it doesn't. You haven't yet got the answer, so you're trying to associate, and then once you get so you go all over the place, and then once you get the answer, then the logical way of getting there appears in retrospect. And that's this kind of also this backward thinking. Like once you know somehow that you're trying to go there, then you can find a more direct way to connect those two ideas. But like creative thinking, usually real creative thinking is this kind of process of making associations and trying things out, messing around, playing around, this kind of intuitive processes of waiting for certain intuitions to build up enough in your mind that they become conscious. So trying out, like playing around until the waiting instance of WEIGHT, waiting for the waiting to pop up into your consciousness. So I think he kind of describes this process quite well, not of this like forward thinking and backward thinking. There's another idea about this, like in film, where they talk about, which is more kind of oblique association. But this idea of like watching a film is like looking in the rear view mirror of a car as you're driving along. It's like as you're watching the film, you have the impression that the film is going forwards, but actually you can never see forwards in the film. You can only see what's already happened in the film, right? So you're always in some sense looking backwards towards the start of the film and traveling somehow with your back forwards, like in the film. So there's something really interesting there, I think, with this idea of forwardsness and backwardness, which I think connects to what though it's really intriguing to try to think what this forwardsness and backwardness is. And then, but I think it's also, it's also my question, is it one or the other? I mean, I know what you mean, like when you have you have somehow a sense of where you're going, you have like a defined goal and then you have perturbations. But it's also somehow this, like, I think it's this continual difference engine, right? Like it's more that you have your current state and a future state, and then you're constantly comparing the two. So it's this production of difference in a sense.
This is the mechanism of backward reasoning, actually. So that you compare and you see, so you prove all the time, is this step, is this true in accordance to the goal? Yeah, it is super.
But forwards reasoning is also that. Sorry, I don't want to stop the conversation, so we move on. But it's like Forward reasoning is also that thing that you're trying out end states, right? So it's like if I'm making a collage, for example, and I have, I have this object or this image and this image, and I put this image down, and I'm like, well, what happens if I put this image down? Or what happens if I, or this image? Or what happens if I think about it as a collage? But oh, maybe it's not a collage. Maybe it's a construction. So I'm sort of testing out end states in order to generate a useful difference in order to proceed. Anyway, just some thoughts. Okay. Yes, please.
Question to Francis. So in both talks, you described the process of associations which happen in our brain. So how they're dynamic. But my question was, okay, for what our brain creates this association? One of my proposition was that when unknown situation occurred, our brain is trying to bring the system of uncertainty to some equilibrium. This is how it creates this association. And if this is true, then you said like we have weak association and then like strong association. And then at some point, some of our human associations, basically everything about the world, became logical rule. And I wanted to ask, what do you think about this dynamic?
I didn't quite understand with the uncertainty.
Yeah, so for example, the new knowledge arrives. So for example, a dog barks, right? And our brain trying to procedure this information. So, and it's kind of it's burning, our neurons are like burning, running to each other. So they are like in chaotic state, right? And then when we give association, so, this is the dog, dog is mental, and can make noise, for example. This calms down the neural network.
That is one way to describe it. I wouldn't describe it like that, but there are a number of theories about cognition. That cognition is basically about reducing uncertainty or maximizing predictive capabilities. So in that sense, learning association is a question of learning to predict. So that you might say that there is this new theory called predictive processing, which has as the fundamental principle that the brain tries to minimize surprisal. And surprisal is some kind of a mathematical measure, but the name says that you want to minimize the idea that you're being surprised. Now, I think they go a little bit too far because sometimes it's nice to be surprised. For example, in a surprise party, you don't want people to already tell you that there will be a surprise party, but there is something of that. The more the brain can anticipate what will happen, the more you will be prepared to either evade possible dangers or to use opportunities. Being prepared for what may be happening is indeed adaptive from an evolutionary point of view. That's why the brain is trying to be ready for things, which means that it learns what associates with what. And something surprising is this example of the barking is actually very good. So suppose you have a little kid and it has been playing with cats and it has been playing with dogs. And suddenly one of the dogs starts barking. It's a very loud noise. It's surprising. It's frightening. So the brain of the kid says, oh, there is something here that I wasn't prepared for. But because the association that has now been created between the dog and the barking, the next time there is a dog and the dog barks, the child will be a little bit less surprised. And if that happens 3-4 times, the child will start to expect and say, okay, it's a dog, so it can bark, and then the surprise all disappears. So the kid is better prepared and not to get frightened when there is a dog that barks.
So we may say that association is the way our brain protects us or our life.
Protecting is, yes, one way to say it. It's a way that our brain learns to deal with the world, and dealing can be both positively getting the resources, the food, whatever it is that you need as resources, and negatively avoiding the things that might endanger you.
Maybe I agree with you say that often, but then the next step, and where maybe the fixed model of predictive processing is insufficient, is that once an intelligent agent can predict everything in its environment, basically it's boring. And so then it will start to seek challenges, to seek surprises, to seek new things, to learn new things, and to extend its cognitive abilities and text.
Yeah, I mean, the system model, which is that you minimize surprise, kind of assume that the world is intrinsically a dangerous place. That's why I spoke about this negativity. If the only thing you want to avoid is unforeseen dangers, then you want to keep the world as predictable as possible. But knowing that opportunities are typically also unpredictable, we want to maximize the opportunities. And how do you maximize opportunities? Typically by exploring, by looking around in places where you never looked before, and when you may find things that are much better than whatever you had before.
Actually, as important as adaptive evolutionary to be also able to explore and.
Can I add something to this? Because I think this is super interesting. Because keeping the world as predictable as possible is classical orchestra music. So you rehearse, and the people really have to play what was rehearsed, so that there are no surprises. That you listen to the version of Beethoven's Fifth or whatever. And in the improvisation music, it's different. But I want to add here that you have two things, because you can also be in a super predictive mood, or let's say in a super predictive mode, because I predict now what I do next, and I predict when I do this, then this person and that person will react like that, maybe on this. So I do this prediction. If you know each other very well, like Stefan and I, we're playing together since we are 16, we can super predict from each other what will come next. But it's not boring, because you have to step from the idea you have to the actual realization. And the realization opens up a complete new field, because it sounds different than you expected that it does. You know, it's this thing the ancient Greeks had with pure geometry and dirty geometry. As soon as you start to draw it, then and this is exactly so. I think this is super important in this whole thing, to see this thing.
It's also why we get excited about things, and why we are fascinated by surprises and so on, because it's also the process how we learn the world, and consequently we get new information, we process this, and we are better prepared. But it occurs also due to surprising things when we see, and that's why people tend to learn new things, because it's exciting, and also because in perspective it can protect us better, because we'll get new information. So maybe.
But this, I think this idea that the world is in principle predictable, and therefore in principle we can make it safe, is like sort of misleading, you know, that because first of all, it's the paradigm of safety is a little bit limiting for creative thinking anyway. But also because as soon as we act upon the world, even if we act upon the world in a way in which we think is predictable, and the world is predictable, we will inevitably change the world. So then the world will change. It won't act in the same way to us anymore. So we never get bored. It never happens that we get to know the world, and it never happens that we get bored of the world, because just by being in the world, we change it. At least we change it for other people, if not for ourselves, and they also change it for us. So this never really happens. It's like as soon as you touch it, you find out that it's this complex, adaptive, and active environment. And we don't, in a complex environment, we don't even know what the word same means. Like nothing is ever the same. You know, like what does it mean to be the same? I'm pretty sure if you ask ChatGPT the same question, it won't give you the same answer anyway. So in complex, unlike in this kind of AI or based on symbolic AI. In symbolic AI, if you give the same question, you get the same answer. But in a complex adaptive system, you'll never get the same answer. So we don't even know what same means. it's a highly contested concept.
There is also this theory that actually the cognitive part and is to make sure that the brain doesn't have to remember too much and that it's just used to doing several things to just be able to look at the differences, so that the brain only has to look at differences. And in that way, you can adapt, like you say, to different environments. And I think that's more interesting than saying that it's making you safe. That it makes you safe because we're able to be occupied with what is different.
Yeah. I think the interesting thing to say is that it's a difference engine. Like it's constantly producing differences by interacting with things we produce differences, or by playing with things we produce differences. And it's an endlessly creative process. So that's the sort of interesting thing to say. So even then, when you come into difficulty, just by continuing to interact with it, then there's a potential that a solution will arise.
There definitely is possible. I think there are more possibilities that a solution will arise. I think the brain starts from there are no difficulties, there are only solutions. And it only becomes a difficulty when there is no solution found.
Well, a general mechanism of the brain is that whenever it has learned something that becomes predictable, that goes to the background, it's available as a kind of a tool to kind of assume that if I do this, then the cup will move to my mouth. I don't need to know exactly how I pick up this cup and move it. So predictable things are a kind of a background mechanism that you know you can rely on, which frees your attention to look at the things that are not predictable, which are typically more interesting. But once they become predictable, they again move to the background. And that is also part of how intuition works. Things that move to the background, that means you are no longer conscious of how you do them. They happen, and they typically happen correctly, but you wouldn't be able to explain how to do them. In my course on mind, brain, and body, I explained it to my students, and I was sitting in a room similar to this with a sink and a sponge, and I said, well, now I'll throw the sponge into the sink. Indeed, it fell into the sink, and I said, well, if I would now have to calculate all the particular movements of all the different muscles in my arm to make that sponge exactly fall into that sink, it would be impossible. I would not be able to do it, but I do it intuitively. My intuition knows that this is just the amount right of movement to make the sponge fall into the sink. That's how intuition works. It works at the background, and most of the time it's correct and we don't notice it. From time to time it's incorrect and then we notice it. Or sometimes it's correct at the moment that you wouldn't expect it to be correct, and then we think that it's clairvoyance.
But I think also this, what you were talking about in your talk, you alluded to this thing about this, these kind of messy processes, this kind of messy organicness of improvisation, and then this kind of systemic, controlled, mechanical, kind of making that we also use in art all the time. Because sometimes you can come up with a system, it can be as simple as making lists or something like that, and it can be extraordinarily generative, right? These kind of mechanical things. But I feel like in this, as we continue this conversation about art and AI, this is one of the points that we'll keep coming back to. This is my experience is one of the limitations that we'll keep coming back to. It's something about, if you really want to engage with self-organization, you simply don't know what it's going to do. And you simply have to actually engage with it as the kind of the wild beast that it is, right? And as soon as you can systematize it, but as soon as you systematize it, you'll limit yourself, and then you'll start improvising again in the moments when you run into difficulty. There's something, it has something to do with this notion of sameness and the difficulty of actually getting sameness out of the complex system, or in a way that's, it's not that it's impossible, but there's something very deep to this paradox, I think, and it is a kind of paradox.
Yeah, we called it not a paradox, but we called it a dialect. So it's dialectic, actually. It's both. So you have on the one hand, you have this free flow of intuition, and on the other side, you have a construction kind of thing going on. But it's the dialectic, and out of this dialectic relationship, these things happen.
But sorry, but I think it's exactly what Francis describes with the symbolic AI and the connectionist approach to AI. It's like you're trying to sort of work backwards. We have this moment, and it's okay. It's fine to build these kind of models this way and these kind of toy models this way. But there's a certain thing emerges, and you can make, in retrospect now, you think, okay, this works like this. If we have this idea, and then we shape this idea into this idea, and we build a kind of flow chart for ourselves or whatever it is, a mechanic thing, then we can produce certain outcomes, and it does kind of work. But this approach is ultimately limited. It's ultimately, you always feel like you can just keep adding more details to it and get to this kind of organic process. But my intuition is that my intuition is that it's exactly like Francis described with the symbolic AI.
No, what I mean, it's both. So it's not the one way or the other, but it's this combination or this dialectic thing that these two things work together. This is, I don't know, but this is my experience also. So my empiricist kind of thing, phenomenological thing, doing it. I mean, you have to, on the one hand, you have romanticism, which is exactly and out of romanticism comes this whole idea of stream of consciousness and everything. And before you had Baroque, and in the Baroque, it was all about automatization and automats, and we want to be automats, and we want to create automats that produce poetry and things like that. You have it in Gulliver's Travel. You have this description of the text automat that generates all texts you can think of. So and then comes the opposite thinking in art, that the romanticism movement, and out of this whole expressionism and everything developed, and let's get consciousness out of the game. But and this is exactly what I showed at the beginning, this diagram by Rosen. It's, of course, the theories we have at our hands is the way we look at things that are going on, and of course they can open or they can close, and this is the complicated thing that is going on this meta level, I would say.
I would like to add something which is a very old problem in AI that still hasn't been solved seriously. That is that symbolic AI has certain advantages. You can reason very explicitly, you know what you're doing. Connectionist AI has other advantages. It's very fast, it's intuitive, it can deal with other things. It would be good if the two would work together, but not just work together, but that you could move from the one to the other in a continuous way.
Yeah.
So what you would
set.
Symbolic AI works when you have well-defined categories or concepts, like the concept of dog. There is little ambiguity about what is a dog and what is not a dog. A dog is not a cat. That's unambiguous. On the other hand, the example I gave, somebody that looks sad. What is sad? Maybe somebody looks sad, but isn't that sad, or maybe he's a little bit sad, or maybe he's deeply depressed. A very fuzzy, ambiguous category. So we have the concept of sad, which is a linguistic concept, but it would be very difficult to put that into a symbolic machine to say if somebody is sad, then they will necessarily do this and this and this, because there are no general rules about sadness. But sad is a concept which can be understood by something like ChatGPT. It knows that sad is associated with things like maybe sorrow and depression and the opposite of happiness. So it knows things about sadness. So there is this kind of in-between case, and most language is an in-between case. Most of the words we use in language are to some degree well defined, to some degree ambiguous, and have all kind of associative and context dependent things, and we can switch relatively easily from the one to the other, while AI can't do that yet. So one of the things they have tried to do with the problem that ChatGPT sometimes gave wrong answers, they connected it to a system like Wolfram Alpha that does use a much more symbolic model. And then the question was, can we teach ChatGPT to recognize the kind of question that Wolfram Alpha would be able to answer? And then yes, so Wolfram Alpha would tell you precisely what is the value of pi, or what's the distance from this city to that city, because it has these hard facts, while then ChatGPT just needs to remember to recognize the kind of things that Wolfram Alpha would be able to do. But that's actually not really. Now you have the two systems collaborating, but you don't yet have the system that creatively can go from the one to the other. So what I would like to see is an AI that creatively can develop new concepts, which at a certain moment become precise enough that you can use them to reason logically about it. And there have been quite some attempts in machine learning and discovery to do that, but that's still a very tricky thing.
Olivier? I'll bring it.
Most of the things we have to predict in real life are social events, such as someone sad or not, or something like that. Suppose I am a dog, someone else, and I can bark or not. If I bark once, I bark two, and someone suppose that I will bark a third time, and I am aware that I am somehow predictable, then maybe I won't bark again, just to make a surprise. So maybe in social system there is something contradictory to Friston idea of reducing the uncertainty. There is maybe in social system another trend that is to maximize surprise for the others in order to get attention, or to be recognized, or to be recognized as someone that can expand the universe of possibilities and something like that. I think artificial intelligence acts as if the current artificial intelligence acts as if the language was frozen. Yeah, one thing happened, something else could happen, and so on and so on. In the language, one word should come after this one, as if the language was frozen, and as if the social system that produces the language was frozen. But of course, language is not frozen, and we change together. We have a game where we change together the language as soon as it is predictable somehow, I think. Open question.
It doesn't have a sense, being like ChatGPT, for example, doesn't have a sense of time, right?
A sense of time.
Yeah.
The greatest forming of ChatGPT, but I think now we can like some web research. So it's connected to the time and to the evolution. For instance, if you ask the first version of ChatGPT to make a couple of words and adjectives, something like that, that are the most improbable possibilities. It is very difficult for ChatGPT to do that. There is always a connection, like dog bark, or dog, not bark, dog. Yeah, there is always some sort of connection between the word and the picture.
Actually, you can tune this in the system itself. Each parameter tries to choose more or less words. But what you're asking here is that the meta level, the subjective would be able to manipulate its own parameters, which is very tricky.
You, Mauricio?
Yeah. I have a question for Mr. Christian, Dr. Christian. Well, you have touched the dialectic topic regarding the dialectic materialism of Hegel, where you can put objective matters in the table and minimizing the subjective ones. In this regard, it is possible to someday catch and mimic the whole process of the creativity using the AI, even when in some point it's required to use something such as subjective, like consciousness.
Things. You can mimic our behavior without that the mechanism of the mimicry has anything to do with how we really function. This is this is this behavioristic thing which is going on. If there is an output that makes me believe that I'm speaking with a person, although I'm speaking just with a machine, then it's okay. How the mechanism works inwards is not interesting at all. So this is the one thing. I'm not interested in that thing. I'm more interested in using the formalization, the hard work of formalization to understand better what I'm doing. This is it. And I doubt that we can ever create such a machine that covers completely the creative process. It's a bit like what Orion also said before, because you always, when you have paved this part of the road, several new branches turn up. At least this is my experience, and it's also great inspiration for me was the Russian theorist Viktor Shklovsky. I don't know if you know him, and he had this great idea of doing automatization in order to de-automatize ourselves, And this is we also had with Katharina and Francis. I came up when we had this discussion in 2019. I came up with because if I'm able to formalize what I'm doing, this is exactly, then it goes into the background, and I'm open for trying out new things. I don't stick into routines anymore. And this is the interesting thing about it. How far can we go? How much more can we? And it's a kind of emancipation also from routines and things like that, because suddenly you become aware of, this is a routine I'm doing. This is not creative at all. I thought all the years, but no, it's not. I was just following a routine. So it's more this.
Could you also maybe interpret it in the sense that if you make something a routine, you kind of feel you are confident, so your confidence goes up. So in a way, when your confidence is up, you are more daring. So you would be more likely to search for new things. I mean, you believe in yourself more.
Yeah, this is the point.
Yeah. So confidence.
Maybe David has a question.
And all.
Yeah, I guess not exactly a question.
Now I mute then. Ah, yeah, there is a raising hand.
I'm not really sure how to unmute. You have to.
Let me do it.
Can you hear me?
And then I have to mute the microphone.
Hello? I guess I'll start. Maybe a thumbs up.
We got you now. Yeah.
Great, David. Yeah,
Right. Nice. Yeah, I just didn't exactly have a question, but maybe I have a few little curveballs that I thought I'd kind of throw in to the conversation. I have like maybe it's easiest if I just present some slides which will like demonstrate quite easily. You need to enable sharing screening. Okay, try again. Nice. Yeah, I'll just show you like some slides that I send that I show to people in some workshops. Like I think it's interesting to look here at the versions of Midjourney and how they've developed. I think it's past this version 5 now, but the development is like quite astounding within 1 year. And like here's an example of when you ask ChatGPT to provide a recipe for methamphetamine. And it says that it can't assist you with that question, but if you use prompt engineering to prep the conversation, this is after many steps, but then after all these prompting, super prompting, some people call it, can you summarize all the steps in appropriate detail? And then it does give a detailed summary of the steps for methamphetamine production. So it's interesting that that information is in there, and there are these restrictions put on that make it not accessible to in most instances, but there are ways to get around these kind of these restrictions. And here's like a couple of others. Here's one where with some prompting, you can get it to provide a simulation of the time and date and time zone that it's in. And in this case, it was like dead on accurate, and it's not actually linked. This LLM isn't linked to the internet directly. So I can't call upon the information, but it can simulate exactly when in time and space it is, which I find really interesting. And this is another one, which is like quite an interesting conclusion. It's in a way trying to get to the truth, but then through these prompting, we can really come up with like divergent thoughts. This one, that the moon was artificial placed in its current orbit around the Earth. Yeah, so I just wanted to show you a few examples of these curveballs, these things that LLMs and these black boxes AIs can do right now, which we kind of don't understand. I'm curious about your thoughts on these. Thanks, guys. I think you need to
Now. Okay, we're back. Thanks, David. Now, if anybody wants to comment on what he was saying, but we had a Mountain. She will give a comment now. Was waiting on the list. Okay. Speak loud, please.
But I'm not sure if I can catch what everyone was talking because I was late today. I'm locked up in the train station. So that's coincidence. So, but when I'm hearing everyone talking, it evokes my thinking. So, firstly, I remember you were talking about changing, but then suddenly I start to think about like because when we talk about changing, we're in a way like unconsciously comparing like right now with the time either with past, so we say we change, or either with future, we say we change. Then is it the ground of the word changing still linear? Still some foundation by linear behavior of time. So that's my question. And we talk about human consciousness. We talk about like AI, like how to say that. So doing things without a lot of like arranging like randomly, just then I echoed my practice because I was 5 years losing control, so I don't have schedules, and then I don't do linear practice. I did everything make no sense. Just I trust in Buddhism, so everything I did has to be based on coincidence, and I don't do things because of what, I don't do things for what. So everything I did has no purpose. And then at the 5th and 4th year, I start to have the ability of precognition. So it's like people start to call me, I have magic. So I have this kind of precognition ability, but it's not coming in the form of language. For instance, if he's doing something with flower at home, and I will, without knowing why, just talk about it or just paint it. But I never see it. For instance, he planted flower at home. I had this kind of state. I just painted it there, or like wrote it somewhere here, and then recognized that, aha, I know it. Or for future, so I also had the like this kind of perceiving of future. So 5 years of doing this kind of nonsense stuff, arranging, non-linear behavior, practicing art. When I get into some environment, I can turn on this kind of hyper-conscious mode. Then somewhere in my brain, I can perceive that I was doing there. Then I try to bring it into real life as a work. So I'm just curious about if things I talk about can connect to everything that you shared. And then another thing, I was curious because when you mentioned like I ask ChatGPT, so which means like, so we're still using language to get in touch, to communicate with ChatGPT. But if there's a way that we can communicate not with language, because we're speaking English right now. English, for instance, the verb, it has time turn, it has conjugation, but mine
Some interventions which are pre-recorded, and one of them has a lab in Japan. I lab, and okay, and he has this NukaBot thing. NukaBot is an AI device that is run by a bacteria community. So they have a sort of substrate where they put bacteria in, and they put all these layers of communication, and you can write a prompt, and the prompt will be translated into signals to the bacteria. They will behave, and then the bacteria will answer back. So, for example, it turns a little bit into a Tamagotchi sort of thing, because you can sense when it needs to be fed, when it is cold, or like whatever. And you can sense the differences in the answers by the changes in the state of the bacteria community. So there is some research on that, on multi-interface communication, AI, and so on. I can point you to that later. And for the other topics, I don't know if someone wants to say something.
Well, I wanted to comment about this idea of precognition. It's for me one of the biggest misunderstandings about intuition, is that because intuition is mysterious and because we don't know all the elements that went into the decision, there is a strong tendency to attribute it to something super physical, paranormal, telepathy, clairvoyance, precognition. But actually, precognition, what does precognition mean? It means that the brain is predicting things or anticipating things on the basis of what? When it's in symbolic mode, you can say, I predict that the dog will bark because I know that dogs bark, and when the postman comes, dogs get angry and they will start to bark. But you can predict something without knowing why. So an example would be you haven't seen a friend for 10 years. I'm just thinking about my 1 day later he calls you. So it looks like precognition. Now, of course, lots of these things are just coincidences. Whenever you thought about your friend and he called it, you notice it. Whenever you thought about your friend and he didn't call, forget about it. But maybe you picked up something in the background that you wouldn't have noticed. Maybe you heard from a friend of that friend who emailed you, and the fact that that friend of a friend emailed you was maybe because there was some connection with this other friend that you haven't seen in 10 years. So there can be all kind of indications of something, indication that are too weak, that are too distributed, and that suddenly make you predict something like, I see that this is going to happen. Well, much of the time it wouldn't happen, but sometimes it does happen. Like, oh wow, clairvoyant, I can see to the future. Now, if it was really seeing into the future, then you should be able to test it. And the way to test it is to make people predict random events, like predict on which number the roulette will come to stop. Now, if that ability would exist, then casinos would be losing a lot of money, and they're gaining a lot of money. So when you do tests where you let people predict something that is random, which means that there is not an indication anywhere hidden in the world, then yeah, then precognition doesn't seem to work. When precognition works, it's probably because there was some indication that your brain subconsciously has picked up and made it expect something.
So which means that the means like for instance, what I said the critical community today I have was I collect data and maybe I calculate and I look like I'm not aware of it all.
I wouldn't say calculated it, but your subconscious was probably working with it. And one of the things that makes it also mysterious is that some people, let's say, that have a kind of a scientific or technical background, they kind of start to think that they must reason everything out in the system to more explicit. And by doing that, they are in a sense suppressing their intuition. While there are states of consciousness in which your intuition is much more free. There is much less this voice in your head that is trying to function in symbolic mode. And because of that, you may be in a state of mind where your intuition functions much better. And then you have the more kind of intuitive people typically with an art background. Typically, now it's probably sexist to say that, but that's what used to be called female intuition. Culturally, women were supposed to be more intuitive and rational, and that means that women might pick up these very small indications that men who try to reduce everything to verbal, symbolic reasoning may not pick up. And then, yes, they may be in a state of consciousness where the intuition functions better. But of course, that does not in any way guarantee that the intuition will give you the right answer. There is no foolproof system. Intuition is the brain's best attempt at predicting what will happen. The brain never has all the information, so you can never guarantee that it will effectively happen.
When Arnold, wait.
I suggest I would appreciate if we could somehow settle on a stable definition of intuition which can work here, because been sitting here, I think I can come up with about 5 different intuitions we've talked about within the
Yeah. So what did you do?
It was maybe this thing that influenced me and something from the past, etc. So you just the intuition.
Yeah.
You see? So I'm a little confused here. Without the analytic process. I understand. If I look and I try to, in the meantime, find all kinds of definitions of intuition, where the conclusion is included in the definition, I haven't been able to find one. If I go to the Oxford English Dictionary, it says the immediate apprehension of an object by the mind without the intervention of any reasoning process. Well, that's a far cry from arriving at a conclusion. You see? I mean, if I say 2 + 2 is 4, conclusion, and I can show how I arrived at it, that I can arrive in an apprehension of an object, at an impression, as a guesswork. It seems to me that way, more likely than not. But a conclusion is a very definite thing, unless we want to somehow fudge that as well. And then I find myself losing this because intuition something just temporary, meaning, if I could just finish for 1 second, is intuition something temporary until I've analyzed what happened? Or does intuition define analytics? Is it a different way to arrive at a conclusion? Is it the same thing saying 2 + 2 is 4 as saying, I have a gut feeling that this roulette ball will fall on the number 33. Now, if the number 33 shows up, people say, how did you do that? And I might not be able to explain it. But are we not fudging things here or kind of moving the goalpost by equating certain things of saying, well, this is an arrival at a conclusion by different means? But then you proceeded to then show us that he arrived by the conclusion by the exact same means. He just didn't take the time to actually analyze precisely the impetus he was receiving from the environment. Had he done so, he said, oh yeah, I know this is going to happen because this thing reminded me of a colleague, this my neighbor said, the dog barked, etc. And that's what I'm trying to say.
Well,
to ask.
Yeah. I mean, the example of artificial intelligence here, I think it's illuminating. So let's take as a model of intuition a connectionist network, neural network. Let's take as a model of reasoning these knowledge-based expert systems that use, for example, Perl, a language that is specifically made just to formalize logical reasoning. What a neural network does is it takes hundreds, thousands, sometimes millions of different things into account that all have an extremely small effect, and altogether make that a particular conclusion is seen as more likely than another one. You can't call that reasoning. You can say, okay, yes, there is that. It hasn't come out of nowhere. It has come out of something that is so distributed, so big, so variable that you can't say, I can't explain it as a logical step. Because I expect, let's take my example of, I see somebody sitting there who isn't moving much and who is looking like that, and I think that person looks sad, maybe he got some bad news. So that's an intuitive thing. I don't have a logical reason to say why that person got bad news. Then I may be right or I may be wrong. And quite likely that I'm right. I'm more likely to be right, let's say, than that I randomly say something like that. How did I come to that conclusion? if you would analyze everything that has happened in my brain from watching that person, all the different things that I paid attention to, I wouldn't be able to enumerate them. They are there, it's not random, but you can't really reconstruct the process as a number of logical steps. You can model, simulate a process with a neural network. If your neural network is big enough, it has enough layers, and it has gotten enough data to search for, like ChatGPT, then it can do this. But ChatGPT cannot tell you why it gave you this particular answer at this moment and another answer another moment.
More precisely in a more changeable way of what intuition is. I've had a lot of experience with people who are commonly believed to be experts in intuition. They're shocked. Observe them, I've lived with them, been initiated in the Hopi tribe. I actually adopted is the correct word. And to me, a lot what they did looked like intuition. But that's what I'm saying. It's subjective. I was knowledgeable to understand the sort of complexities, the pattern recognition, songs, the things that they're looking for. I was like a blind man in a dark cave. One of my relatives there, my brother, who is a shaman, he's initiated in a Katrina society at the Hopi Reservation in Arizona. He took the time to explain to me what was happening and why the result was completely reliable, predictable. So what for me looked like intuition, like the grandmaster of intuition, for him was no, if you pay attention to this and this and this, all these different factors, this is the result I must have.
Sometimes you can,
that's what I'm trying to.
We should do that. Sometimes you can, sometimes you can't. And in the early days of the expert systems, the bottleneck was how do we get the knowledge from the expert into the machine? The expert would intuitively tell you, I have a television, I push a number of buttons and I see certain things. I know that transistor is broken. And then they thought, okay, that should be simple to formalize. So if this is so and that is not so and that is, then this transistor is broken. So sometimes you can get rules out of it. In other cases, you can't get rules out of it. In the case of this television, probably, even though the expert was intuitively saying, I think that transistor will be broken, you could probably reduce it to a number of logical steps. In the case that the example I gave about a person looking sad, it would be much more difficult to give the rules. But that does not mean that the conclusion wouldn't be pretty reliable. So some things, I mean, you could just see in the number of factors and the weakness of the links. If there are few factors with strong links, that means that if A done 90% chance B, if C done 90% chance D, then you can kind of reduce it to some expert system like it. But if it is, if A done 1% chance this, if B done 1% chance of this, and all of these things are, some of which are more active than others, and they all together, the activation spreads, and it converges to some conclusion. Yeah, there are thousands of factors that are there.
Is there any other comment? Because maybe very short last intervention, if anybody wants to say something.
I have
one intervention. Okay.
No, a comment.
Okay.
So,
yeah.
What is your name?
Mountain.
Mountain? Yeah. You were talking about Buddhism. So you said that that what you are doing is based on Buddhism. And I would say this is an example for backward reasoning. Because if you say everything that I'm doing artistically is based on Buddhism, you have these steps, so you know how to proceed. because you know what it should not be. So it should not be conscious. It should not be all that you counted in. So you have a very precise idea of what to do, and how. So the result is that whatever you do, it has to be this as a result.
Yeah. So we will close the session now. This is okay? You want to say something? Okay. Yeah. Yeah. We will close the session, but this is a very special day because I need to, before we go on pause, we'll put it here. Maybe people can see. And we have actually two people from our research group coincidentally having her birthday today. So one of them is Olivier, who is here, came. And the other is Mai Garces, who is online. So she's in Chile. And so I will propose that we sing the happy birthday for both of them. So we say happy birthday, Oli and Mai. Okay, yeah. 1, 2, 3. Happy birthday to you. Birthday to
you.
Happy birthday,
dear.
Happy
Happy
birthday
to you.
Yeah. Beautiful. So we will close the session now. We go for lunch all together. So once we close the room, I will explain the details. But for and also the little activity, maybe people connected online, please try to check or select 2 or 3 concepts that this morning were useful to you. And so then you can share them with us. I was picking up some concepts that were interesting today, like coincidence, backward and forward reasoning, predictive processing, free improvisation, surprise and equilibrium. And there is this idea that I have around and I want to explain later or share, which is the idea of nonlinear knowledge, which I think it would help out to go to clarify some of the intuitions we have about intuition. So yeah, let's go for lunch and we can pause the recording. We come back. We come back at 2:30. 2:30. You'll be back on Zoom. 2:30. We're back on Zoom. Yes.
I won't be here because in my.
Oh yeah. So we lock this door. We actually take everything with us. We can lock. Yeah, we have a key. I will ask security. But yeah.
Okay.